Hi everyone. Today we are going to discuss some questions on linear differential equation. A linear differential equation of the form dy by dx plus ty is equal to q, where p and q are functions of x only or constants. For solving this, we have to find the integrating factor of the differential equation. Integrating factor is e raised to integral p dx. Now the solution is y into integrating factor is equal to integral q into integrating factor dx. So this is the solution of a linear differential equation. Now let us discuss some questions based on this. First question is the integrating factor of 1 plus 2 e raised to minus x into dy by dx minus 2 e raised to minus x y equal to 1 plus e raised to minus x. First we have to write this equation in the form dy by dx plus py is equal to q. For that we have to divide the whole equation by this 1 plus 2 e raised to minus x. So we will get the given equation as dy by dx minus 2 e raised to minus x divided by 1 plus 2 e raised to minus x y is equal to 1 plus e raised to minus x divided by 1 plus 2 e raised to minus x. Now this equation of the form dy by dx plus py is equal to q, where p is equal to minus 2 e raised to minus x divided by 1 plus 2 e raised to minus x. We have to find the integrating factor. Integrating factor is equal to e raised to integral p dx, where p is minus 2 e raised to minus x divided by 1 plus 2 e raised to minus x. To integrate this, we can substitute 1 plus 2 e raised to minus x as t. Now take the derivative, we will get minus 2 e raised to minus x dx is equal to dt. Now this is equal to e raised to integral minus 2 e raised to minus dx as dt by 1 plus 2 e raised to minus x as t. We will get e raised to integral of 1 by t is log t, or it is t. So t is 1 plus 2 e raised to minus x. This is the integrating factor of the given equation. Now we will move on to another question. Let y is equal to y of x be the solution of the differential equation x cubed dy plus xy minus 1 into dx is equal to 0, where x greater than 0, y of 1 by 2 is equal to 3 minus 3. We have to evaluate the value of y of 1. First of all, we can write the given equation as a linear differential equation. For that, we can write this as x cubed dy is equal to 1 minus xy into dx, or we can write this as dy by dx is equal to 1 minus xy divided by x cube. On the right side, we can divide each term on the numerator by x cube. So we will get dy by dx is equal to 1 by x cube minus xy by x cube. Xy by x cube. Here we can cancel 1x and x cube. So we get dy by dx. This is minus y by x square. So 1 by x cube minus y by x square, or dy by dx plus y by x square is equal to 1 by x cube. Now this is of the form dy by dx plus Py is equal to Q. To solve this differential equation, we have to find the integrating factor first. So the integrating factor is e raised to integral p dx. So in the given equation, p is 1 by x square. So we will get e raised to integral 1 by x square dx, or it is e raised to integral x raised to minus 2 dx. So the integral is e raised to x raised to minus 2 is minus 2 plus 1 divided by minus 2 plus 1. So we will get e raised to minus 1 by x. So this is the integrating factor for this equation. Now we can write the solution for this. Solution is of the form y into integrating factor is equal to integral q into integrating factor dx. Or we can substitute the value of integrating factor here. We will get y into integrating factor is e raised to minus 1 by x is equal to integral q is, so in this equation q is 1 by x cube. 1 by x cube into e raised to minus 1 by x dx. Then we can write this as integral 1 by x cube as 1 by x square into 1 by x e raised to minus 1 by x dx. To integrate on the right side, we can substitute this minus 1 by x as t. Now take the derivative, we will get it as minus into minus 1 by x square. So 1 by x square dx is equal to dt. Solution is y into e raised to minus 1 by x is equal to integral. This 1 by x square dx, you can write it as dt. And this 1 by x here, which is minus t. So it is minus t into e raised to t dt. On the next step, we can take minus outside. So minus into integral t e raised to dt. For integrating this, we can take this t, which is our first function, and e raised to t as our second function, which is equal to minus into first function in t into integral of e raised to t, that is e raised to t, minus integral of derivative of first function, that is derivative of t is 1 into integral of t. This is equal to minus of t into e raised to t minus integral of e raised to t is e raised to t plus constant of integration. So if we multiply this minus sign, we will get this as e raised to t minus t e raised to t plus c. Now we can substitute the value of t here. We will get y into e raised to minus 1 by x is equal to e raised to t is minus 1 by x minus t again is minus 1 by x. So this will become 1 by x into e raised to minus 1 by x plus c. Now we can divide this equation throughout by e raised to minus 1 by x. So we will get y is equal to 1 plus 1 by x plus c into e raised to 1 by x. So this is the solution of the differential equation. Now we have to find the value of c. The solution is y is equal to 1 plus 1 by x plus c e raised to 1 by x. Then to find the value of c, it's given that y of 1 by 2 is equal to 3 minus e. So meaning of this, if we put x is equal to 1 by 2, we will get the value of y as 3 minus e. So we can write this as 3 minus e is equal to 1 plus 1 divided by 1 by 2 plus c into e raised to 1 by 1 by 2. That is 3 minus e is equal to 1 plus This 1 by 1 by 2 becomes 2 plus c into e raised to again 1 by 1 by 2 is 2 e square. Or you can write 3 minus e is equal to 3 plus e square. You can cancel this 3 on both sides. Or we have minus e is equal to c e square. Again here you can cancel 1 e. You will get minus 1 is equal to c e, or c is equal to minus 1 by e. Now substitute the value of the c in our solution. We can take this as an equation number 1. We will get y is equal to 1 plus 1 by x plus c is minus 1 by e into e raised to 1 by x. Or it is 1 plus 1 by x minus, we can write e raised to 1 by x minus 1, because this is of the form a raised to m pi a raised to n, which is a raised to n minus 1. So we will get y is equal to 1 plus 1 by x minus e raised to 1 by x minus 1. So this is the solution of the differential equation. And in this question, we are asked to find the value of 1, y of 1. So y of 1 is equal to, put x is equal to 1 here, you will get 1 plus 1 by 1 minus e raised to 1 by 1 minus 1. That is 1 plus 1 is 2 minus e raised to 1 minus 1 is 0. E raised to 0 is 1. So 2 minus 1 is equal to 1. So the answer is y of 1 is equal to 1. So this is the answer. Okay, thank you.